Okay, so let's look at Newton's first law. It says that an object, this is an object right here, it continues in a state of rest, as you can see it rested here, or uniform motion, which is constant velocity. Either it's at rest or it's on constant velocity, just moving constantly. So it will continue like that unless it is acted on by a net force. So it continues resting like this unless a net force comes in through, like this one. Here's a net force, pushes it. It continues at rest unless a net force pulls it. That is Newton's first. Let's look at this. We have a car here and a person on the car. So the car moves and it bumps a house, and then the person continues to move like that. Now, that property of this person wanting to continue is called inertia. Now let's look at Newton's second law. It says that by demonstration here, you can see the car is pulling on the sheep over there. Now, the car is applying a force on the sheep. Now, look at this. It says the acceleration is actually directly proportional to the force, okay, the resultant force, and inversely proportional to the mass. Okay, that is just a brief demonstration, but let me give you another demonstration. Okay, let's take a look at this. Now, as this a car lifts up the sheep over there, there is actually a tension force on that string, such that even if the car was to move, okay, there is a tension being applied on the string. And the tension here, let's assume this is horizontal and that's vertical. The tension here on the horizontal is the same as the tension there on the vertical. Okay, let's talk about an incline. So here we have a calf standing on an incline. What I want you to know is that the weight of the calf always acts right there, like that, straight down vertically, and that's because the gravity always acts vertically as well. But the normal force of the calf always acts like that, perpendicular, okay, perpendicular to the incline. Okay, so that when you resolve your forces, then you make this your x and that your y. So then you need to resolve your weight into x and y. That's it. Newton's third law. Here's a demonstration here. We have body A, which is this blue car, and then body B, which is this white car over here. Now, Newton's third law says that if body A is applying a force on body B, then body B is applying a force that is equal but opposite in direction. Okay, so look at this. Body A, body B come together. They apply equal forces in opposite directions towards each other. Okay, Newton's law of universal gravity. Now, it says that, first of all, you have two masses, mass A and mass B over there. Now, let's say this is planet Earth and that's the moon. First of all, there is a force of attraction between the Earth and the moon. See what just happened there? That's it. Now, this is also a formula, and it says force is proportional to the product of the masses. So the product of the masses, there you multiply the masses, okay, but inversely proportional to the square of the distances between them. So depending how close they are from each other, that's how strong the forces will be right there. The closer they are, the stronger the forces.